Hello everyone, my name is Jim Garrity. In the corner of the workshop, just down there, is my compressor. It's been my compressor now for over 20 years, and it was 40 years old when it was given to me. Other than the occasional oil change or replacing the V-belt, I don't see much of it. And like a lot of old machinery, it was built to last, and last it has done. The manufacturer is a company called Ingersoll Rand. It's their Model B compressor, and it rolled off of the production line in 1954. That's 66 years ago. Well, it was happily compressing air one day when it let out a crack and a well, I turned around and hit the off switch, which is up there by the door, and oh, glue, my compressor's gone wrong. Now, let me take you to the corner and I can show you what's wrong with it. Here's the compressor. We've got the reservoir at the bottom, electric motor. That's a single phase 1 horsepower electric motor. The plate on the side says 1,425 RPM. And the compressor itself is at the rear. You can see it's here. It's a V-twin type compressor driven from the motor by a V-belt, which is at the back. Now, the problem that I have is that the electric motor, you can see here the motor moves. The mount is actually broken at the bottom. A friend of mine says, I have a motor you can use. He tells me it's going to need a coat of paint, but it has a cast iron base which will be much stronger than my original motor. All I need to do is swap the motors and the compressor will be working again. Well, that sounded simple enough, no problems there. Well, he brings the motor over. It's larger than my original motor and definitely needs a coat of paint. It weighs about as much as a small car, but it's not going to break, and best of all, it's free. This is a single phase motor, and we have a starter capacitor here, but it's quite large. It's larger than the motor that's on the compressor, and he thinks it was 2 horsepower, and I quite believe it because it is quite a chunky beast. It spins quite nicely on the shaft. That's nice and free. Although if I'm going to use it, then I will check the bearings and also give it a coat of paint, because you can see there's not that much paint left on it. There's also no plate on there. There's no manufacturer's plate, so it doesn't say what the voltage is, although it's going to be single phase, so we are assuming it's going to be 240 volts. We have a starter capacitor, and we got the plate off the electric connections here. We should have a look at those later on. I've turned the motor up on its end. It's actually on the pulley, and you can see the plate has come off now for the connections, and that's what it's looking like inside. Remove the mains lead first, I think. Now, oh, that's nice. That one. Right, now we should be able to pull this wire out. Just like that. And that's the capacitor off. Well, I've now removed all the wires from the connection plate. It was a little bit harder than I thought it was going to be. I think it must have got damp sometime in the past, because some of the nuts are actually rusted, and you can see a little bubble of rust coming out on some of them. Anyway, I managed to get them all off, but then the big problem is at least 2 of the wires, the insulation that runs down the wire has started to crumble and come off. So that means I can't start this motor until after I've replaced those wires. Now, the wires, they normally go back to the coils, and what I'm going to have to do is cut them off of the coils, or desolder them if I can, and then put new wires on the inside of the motor. Let me bring you down and have a look at these wires. Now, the first wire that I noticed had a crack in it was this black wire just here, and you can see along there that the insulation has started to crumble. If I squeeze it a little, you can see it just crumbles off, and that's no good. The insulation on that wire there, which I'm pointing with my thumb, that started to crumble as well. So all hope of a quick wire it up and see if it works, it's gone out the window. So I'm now going to have to take the plate off. I wasn't going to take it apart until I'd just checked that it had worked. But I think what I'm going to do now is take the end caps off, check with a meter across the wiring, see if the internal coils are okay. Right, let's do that then. Right, so I want to take the end plates off the motor, the rear and the front. But before I do that, I need to take the pulley off the front of the motor. I've just checked on the internet to see how these taper lock couplings work, and you need to take out these two screws, which I had done. So there's one, and then you take out the second one, and then this one needs to be replaced in the bottom. There was some dirt in there which I've now scratched out, so this fits quite nicely. So you screw this in, and this acts as an extractor for the cam. So tap it with my hammer. And the pulley is going back now, leaving the taper lock behind. And that, I think, yep, that's off. Now we should be able to pull the centre piece out first. Like that. So we have the centre lock part. Oh, it looks like it's been shimmed down. Well, it has. It's definitely been shimmed down here. There's the screw which we just put in as the extractor. There's the taper. So that's the first piece, and the pulley itself. It's a cast iron pulley. It's quite heavy. And that's it. Off. Okay, so we've removed the pulley off of the shaft end. That's gone. I've removed the 4 studs which go all the way through to hold the motor end caps on. So now it's just the fit and the rust that's holding it together. Now I will grab my rubber mallet, and we're going to take the rear of the motor off first. So I'm just going to tap. Yes, I found a punch. This flat piece of metal will spread the load over a larger portion of that lip, so I won't mess it up. But it's actually moving quite nicely and quite easily. And we're about to take the rear cover off. And it's slipping off really nicely. And we've got some dead insects. Nice little pile there. I think the spiders have been busy there. Right, I've also got a wire here. Now, let's grab my little spanners. And that's taken off. That was actually 4BA. Right. Let's see if the rotor pulls out of that front bearing. I've cleaned the shaft up. Oh, look at that. That's coming out really rather nice. And there we are. Now, do we have any shims? There's no shim as such, but there are 2 washers. You notice the washer on the left-hand side has got a tab that engages into the rotor, which is on the right, and the washer in the centre is a curved spring, so that adds a little bit of preload. And we've got exactly the same setup on the other end of the rotor as well, so that must keep the rotor in the centre of the motor. One other thing is it has plain bearings. If you look down there, there is a little felt pad at the top, and oil ways that zigzag across the surface, and that's the same for the front of the motor as well. We have a plain bearing down the bottom and a dust shield there around the bearing. The rotor, as the rotor speeds up, centrifugal force pulls these weights out and then lifts, or this plastic piece goes in, moves towards the centre of the rotor. As it does that, then the switch, which is on the back plate here, opens. So when it's in its closed position, it's out, which means when it's 0 RPM, this is connected to that. Now that sort of makes sense, because that means that this could bring in a capacitor on the windings for the starting of the motor, and then once it gets up to speed, then the weights will fly out. As they fly out, this bush moves in. As it moves in, these two sliders which are against it come away and disconnect the switch there. So that makes sense to me now. The rotor is fairly good condition. There's nothing wrong with the bearing surfaces here, because that's actually a bearing surface now, as is that, and both are fine. Well, I've just had a happy half hour getting very intimate with this motor, and I'm now pleased to say it's clear in my own mind how it all works and what's connected to what. Right, single phase motor. This is the stator. The stator has two sets of windings. It's got the run windings and also the start windings. Now they're multiple windings, but they're all connected together, and they come out on these 4 leads. The 2 leads across here are the start windings. I've checked with my meter and they come out at 8.1 ohms. The 2 wires here are the run windings, and they come out at 2.1 ohms. Now with that meter, it's a very low voltage meter. I checked to see if there was any resistance between the coils in case they'd shorted out, and there wasn't. Also checked it to the chassis as well, and there was no current path there. But of course, that is with a low voltage meter. What I have here is a high voltage meter. Now I've set this at 500 volts, and what I want to do is check that the isolation between the coils is still okay, and also the isolation between the coils and the chassis is still okay, and okay is as high a resistance as we can get. So if I turn the meter on, as I said, it's set at 500 volts. At the moment we are connected to one side of the start windings. If I go to the other start windings, this is now a short. So if I press test, you'll see the test voltage displays at the top, and underneath is the resistance in megohms. If there's a short like there is now, the meter won't be able to produce 500 volts because it's being shorted out, and so that should read 0, and this will go down to 0 also. So if I press test, you can see the top one we're at 3 volts, and megohms is shown as 0. So we know that is a short across there, which we'd expect because that's the coil. If we now keep on that end of the coil, put this lead onto the chassis, and now press test, you can see that the voltage goes up to 530, and the resistance in the large display at the bottom, it says 1 megohm, but that's showing that it's full range, so it can't detect any resistance there, which is good. That's very good news. So if we now unclip this end, right, so we now test the run coils. So I've gone between the 2 terminals here, press test, and we've got 0 megohms and not much voltage at all because it's shorted out. Now we go between the coils, so this is clipped onto the run coils. I'll now go on to the start coils and press test, and we've got 36 megohms. The meter is still able to maintain the 530 volts, but there is a slight leakage between the 2 coils, and it's showing us at 36 megohms. Now that's at 500 volts, which is double the normal voltage. In house wiring, the minimum you're allowed is 40 megohms. So this is on the low side, but I think it's high enough to give the motor a test at least. Right, it's time to start cleaning up the stator. I've got this white dust and there's lots of cobwebs as well to clean up. And what I'm going to do, I'm going to clean it with a brush, but also with a vacuum cleaner because I don't want to breathe in any of this dust. So I just need to turn the vacuum on. Now we'll start to clean. Well, I finished that little bit of a clear up and I'm pleased to say the windings are looking good. A lot of that dust just came away with the brush, and I can see the enamel on the wire and it's all looking good. There's nothing peeling off, there's nothing scraped. Yep, it's looking good so far. I'm going to take the front of the motor off now and clean that end of the stator up. The front of the stator is looking good as well. All the dust has come away. This is the front plate of the motor. This is the rear motor cover. I've got to clean this up, but I've also got electrical work to do here. This is the centrifugal switch, or a part of the centrifugal switch. The actual bob weights are on the rotor and they push against these two pads here, these two shiny pads, which open and close the switch, which is down there. There's one terminal, which is at the bottom. This one at the top isn't a terminal, that just retains the top of the switch. The wiring, as you can see, is pretty awful. The insulation is completely shot and it's crumbling and it's coming off. This, I'm pretty sure, is a temperature sensor, and I'll be having a look at that. I'm not sure if I'll be putting that one back in, but I'll have a look at it anyway. And this here is the back of the connection plate. Let's change this wiring and clean everything up. I'm over on the wiring bench now. Now, the first thing I want to do is just make notes so I know which wire goes to which side of this. Now, I don't think this is a polarized component, but I still like it all to go back the way it was. Two securing screws here and here, each side of the connection plate, I've managed to loosen off now. The connection plate is off. Next thing to look at is the temperature sensor, which is this component here with the two wires coming out of it. I've now taken notes as to where they go on the connection plate. So let's see if we can break the threads. That one's tight. That one's moved. And this one really doesn't want to go. Going to give a quick squirt of penetrating fluid, but I can actually feel the screw flexing, and I'm pretty certain it's going to snap off. That means I'm going to have to drill the case, but it does not want to go. Right, I'm going to take the loose screw out. I'm hoping that this will slide out. Does it matter if this gets broken? I'm probably going to put a new temperature sensor in anyway, but I don't like breaking things. Something's broken. There we go. Like that. And a pair of mole grips. And then move it backwards and forwards. I wonder if I should put some heat on there. I now have the rear plate in the vise. I have my small blow lamp. So let's give this screw some heat. It's going to burn the paint off, but that's no problem. I'll try with the screwdriver first. What do you know? unscrews straight away. A little bit of heat, that's all that was needed. To clean the terminals, what I'm going to do is use a piece of white paper. I'm not keen on using abrasives on contacts unless they're really burnt, then you need to. But I just hold them together and pull this through, and you can see the amount of dirt that's brought away. Let's do that again. A little bit of isopropanol, which will also soak through to the other side between the contacts. Hold the contacts down, and you can see the dirt that's coming away from them. And what do you know? No more dirt is coming away from those terminals. So I think we'll say that that is a done deal. Well, originally this was going to be just a short information video for the workshop records. It'd show the old motor coming out of the compressor and the replacement going in. And I record things like that as it saves a whole load of information for the next time that I have to work there. Well, then I discovered the crumbling insulation on the motor internal wiring. Once I decided to have a go at repairing it, I thought this may be of interest to others. So here we are. The motor is completely in pieces and all that old decaying wire is exposed. In the next video, I'll replace the wiring to the stator coils and reassemble the motor. And it's at that point that we'll find out if the motor runs or not. Times are getting interesting. Could you do something like this? Of course you can. And with that, this video is at an end. Take care everyone, and I'll see you next time. Could you do something like this? Of course you can.